Unit 3, Topic 2, Polar form. Polar form, our 3D vectors are written as r, theta, phi. In 2D, it was just r and theta. Phi is our altitude angle, that giving us our three dimensionals. Now we go with r as our magnitude, can be referred to as the norm. Theta is our azimuth angle, which is our angle in the XY plane. Phi is our altitude angle, so it's going up and down. So the altitude angle will go from -90 to 90. To convert, if we're converting from polar form to Cartesian form, we need these conversions. Now, when we did it 2D, we didn't have this section, and we didn't have the Z, obviously. So it was x equals r cos theta, y equals r sine theta. We now have r cos theta cos phi, r equals sine theta cos phi, and z equals r sine phi. So for example, we had the vector 4, 150, 30. So that's a magnitude of 4. The direction on the XY plane is 150. And the altitude is 30. To find x, we're going to go 4 cos 150 cos 30. Sorry, move it over. Y is 4 sine 150 cos 30. And z is just going to be 4 sine 30. Oops. So on my calculator, I'm just going to go 4 times cos 150 times cos 30. Of course, I could do this tech-free because these are nice, easy angles for me to do, but I'm just going to use my calculator. Times cos 30. And then 4 times sine 30. 2. So in component form, it's -3i plus root 3j plus 2k is the equivalent in component form of our polar vector. Now we then have, okay, I want to convert the other way. I want to convert to polar form. So we're going to polar form. So if I have the vector, let's call my vector, let's go root 3, 1, 1, right as a column vector. So my x is root 3, my y is 1, and my z is 1. I want to go to polar form. So r is the square root of root 3 squared plus 1 squared plus 1 squared. Root 3 squared is 3, plus 1, square root of 5. Tan angle is y and z, so it's 1 on root 3. Now remember, tan's the one we should always be checking our quadrant that it's in. We can't just totally rely on our calculators, because if we go on our calculator and go shift tan brackets 1 on square root of 3, close my brackets, it does tell me it's 30 degrees. But we always check that in our XY plane, because remember, azimuth angle is in our XY plane, we're at root 3, 1, so we're here. So yes, 30 degrees is correct. But we need to be careful. If one of the numbers was negative and we were in another quadrant, we need to check that out. And then we look up to a thing, so sine phi is z on r. So that's 1 on root 5. So we're doing that straight on our calculator. Shift sine in brackets 1 divided by square root of 5. Close my brackets. And I got about 26.6 degrees. Oops, sorry about that, 26.6. So in polar form, I'm writing that as root 5, 30 degrees, 26.6 degrees, and that's in polar form.